Here we'll look at working out a value for Kc, and we've been given different numbers of moles of reactants and products, so we will need to know the volume that the reaction has taken place in. Again, we're going to set up a rice table, and we've been told I've got 2 moles of E reacting with a mole of F, no moles of G initially. I've been told I've got 0.8 moles of G at equilibrium. So the moles of G will increase by 0.8. The equation tells me for every mole of G which forms the same number of moles of F will react, because I've got the same mole ratio here, 2 moles react to form 2 moles. So this will go down by 0.800 to give me 0.2 moles at equilibrium. The equation tells me for every mole of E which reacts, 2 times that number of F will react. So if this goes down by 0.8, this will go down by half of that, 0.400. So let's double check that again. For every mole of E which reacts, 2 times that number of moles of F react, and that's just this 1 to 2 mole ratio. This then will give you 1.6 moles at equilibrium. So now let's set up my expression for Kc. And Kc is concentration of G squared divided by my concentration of E times the concentration of F squared. So again, it's now time to populate my expression. So Kc equals the number of moles of G is 0.8. But of course I need a concentration, so I need to divide that then by the volume, which is given here as 1.50. So it's 0.8 over 1.5. That's my concentration, but remember, all this needs to be squared. That's divided by the concentration of E. Well, my moles of E is 1.6. And again, the volume is 1.5. So that's my concentration of E times the concentration of F, which is the moles, which is 0.2. Again, over the volume of 1.5. And again, this is all squared. So that's my populated expression. And when you work all that out, you should get a Kc value of 15. The units, well, you've got moles per decimetre squared, cancel with moles per decimetre squared. So again, the units are 1 over moles per decimetre, which is moles minus 1 decimetres cubed. And that is your answer.